Alright, y'all. Time for to check your problem 4. Let me get it focused here. Find cosine of theta and tangent of theta if the cotangent of theta equals 5/8 and sine of theta is greater than 0. So I'm going to do a little bit out of order. I'm going to figure out which quadrant it's in. Cotangent is positive here and here. Sine is greater than 0. Well, sine is greater than 0 here and here. So the only place where both of them is true is quadrant 1. So again, this is going to be an easy problem. All 4 of them are going to be, all 6 are going to be positive. So I write the one that's given. Then I write its reciprocal. Those are always the easiest ones to start with. So cotangent is 5/8 and tangent is 8/5. And then I apply a Pythagorean identity, and I want to use one that involves cotangent or tangent. So to mix it up, I haven't used this one. I'll use 1 plus cotangent squared equals cosecant squared. You could have done it with the tangent squared plus 1 equals secant squared. I plug in what I know. Because I know cotangent's 5/8, so I have to square it, and that gives me 25 over 64. I've got to make this 1 into 64s, so it's 64 over 64. 64 over 64 plus 25 over 64 equals 89 over 64. So 89 over 64 equals cosecant squared. I take the square root of both sides, and I only need the positive one. I don't need the negative one because we're in quadrant 1. And I get the square root of 89 over 8 equals cosecant theta. So now I have 3 of my 6. I'm going to flip this one to get its reciprocal identity, which is sine. So when I flip it, I get this reciprocal identities, but I can't leave the square root of 89 in the denominator. So I square root 89, square root 89, what I call a fancy 1, and I get 8 on the square root of 89 over 89, and that is my sine. And again, it's positive because we're in quadrant 1 and everything is positive. Now I have tangent and cotangent. I have cosecant and sine. At this point I said you could use any formula that works. You can use tangent equals sine over cosine because you know tangent and you know sine, and all you would need is cosine. You can use sine squared plus cosine squared equals 1. You could use tangent squared plus 1 equals secant squared. You can use oodles of them. I'm going with this one because it's my favorite. Okay, so I've got to square this. I don't know why I put a bar underneath it. I was forgetting which one I'm going to have to get a common denominator on. Okay, so to square this, I'm going to square 8, which is 64. I'm going to square the square root of 89, which is 89. Now, y'all, I'm taking a shortcut. I don't feel like doing all the math. And I'm going to show you what I mean. 8 squared is 64. The square root of 89 times the square root of 89 is 89. On the bottom, I have 89 squared. Why work it out when you know an 89 is going to cancel? So now I've got 64 over 89 plus cosine squared equals 1. I need to turn the 1 into 89s. So it's going to become 89 89ths. 1 is 89 89ths. Move the 64 89ths over by subtracting it, and I get cosine squared equals 25 89ths. Take the square root. Square root of 25 is 5. The square root of 89, I can't work. So then I fancy 1 it. And I get 5 on the square root of 89 over 89. And that is my cosine. 5 on the square root of 89 over 89. Now I have 5 of the 6. I only lack 1. The one that I lack is secant. And so with secant, you need to flip cosine. So when I flip this, I'm going to get 89 over 5 square root of 89. I'm going to fancy 1 it. And now I'm going to have 89 on the square root of 89 over 5 times 89, because the square root of 89 times the square root of 89 is 89. The 89s are going to cancel, and I'm going to get secant theta equals the square root of 89 over 5. An easier way to think about that is back here when you had it squared. If cosine squared is 25 over 89, secant squared is 89 over 25, because they're reciprocals. And then if you want secant, it's the square root of 89 over the square root of 25, which is 5. But I had all 6 positive because we're in the first quadrant. And that is problem number 4. Alright, I want you to try one now that has lots of positives and negatives to run around in. So I'm going to stop this video, but we'll do another one. I'm going to ask you to do for me problem number 5, please. I'm going to ask you to do for me now problem number 5, and then come back to the next video and we'll see if you're right. So if you will do problem number 5.